So the intent of this is to ask us questions. We should, I guess, introduce ourselves and move on to our background. Well,
go ahead.
Why don't you go ahead, sir?
Okay. Went to Michigan State and got out of school and headed to Houston, where I worked at various NASA contractors for about 10 years and worked on the thermal tile simulations for the space shuttle, things like that. And got tired of listening to Congress threaten to, do away with my job. So I went out and became a contractor and sort of wandered for 10 years. Worked at an oil and gas training company, hospital information system company, things like AutoCAD kind of company. And then eventually ended up going to work for ExxonMobil. So I've been with ExxonMobil for about 22 years now. Started working with writing reservoir simulation software for them. And from there, I did a bunch of other things, became an architect, which meant basically I walk around and tell people how to do things more better. And I was the .NET, when .NET was a rising star. I was the, .NET champion kind of thing. We went around and helped people assimilate the Kool-Aid from Microsoft. And then about 12 years ago, I came up to New Jersey because our main office is in Houston, and started to work for ExxonMobil in the research center. And what I do there is I help the researchers do computational research. So they come up with really cool ideas and really cool formulas. And then we figure out how to put them into software. Some of that software runs on massive clusters, which we can now disclose have, about a couple 100,000 cores. And kind of play with MPI, C++, Python lately a lot. I've done some modeling, linear systems, nonlinear system stuff. Now, I'm not the scientist. I'm the guy that if you say, I need to do this, how do we do this technologically? And then I take the hill for them. So that's kind of what I do. I've been kind of doing it all whole life, I guess. Same sort of thing.
Yeah. Why not go up and I can't be seen? Well, there I am. I can be seen.
Oh, yeah,
there we go. Barry Burd. I've never done an honest day's work in my entire life.
Congratulations.
Thank you. I teach at Drew University in Madison, New Jersey, and I've never been out of academia. Never, ever, ever. I know absolutely nothing that's practical. I've been working with Mike for what is it now?
I would say 20 years now.
20-ish years. I've been working with him. I've been a member of his Java user group for 20 years. And most recently, in the last 6 or 7 years, I've been a co-leader or something like that. And that's me. Here we go. Okay.
So yeah, Michael Redlich. I started the what was once known as the ACG&J Java user group. Their ACG&J is a nonprofit, but we went on our own 2.5 years ago. During the pandemic, we actually did this together. And we're our own nonprofit now, and we rebranded as the Garden State Java User Group. There's a few stickers left here for your laptop. What Barry failed to mention is that he's actually a co-director of the new rebranded group. When we went nonprofit, we got our own tax-exempt status, all that. And so there's 4 of us that are directors. Barry was around for all those early days in ACG&J. We've been doing a lot of work in the Java community. Java in Education, which is an initiative sponsored by Oracle. There's, opportunities to go to the high schools and present talks on Java to the high school students, which Barry has done with some of the other leaders in our group. So that's been, working real well. And I'm also a work colleague of Chuck's, and I've been with ExxonMobil, or Heritage Exxon and ExxonMobil for 33.5 years. I was in IT at one point, so we can discuss my career over a beer one day. But the last number of years I've been practicing polymer physics. I use my IT skills for data processing and things like that. I'm going to retire from the company at the end of May, but I'll continue doing my work in the Java community, which is not only just a Java group, but I do writing for InfoQ in the Java space. I'm a committer on 2 of the Jakarta EE specifications, which is the now open source version of Java Enterprise from the last, from 6 years ago. So that's been some good work going on there. And what else? Just they'll be able to go to more conferences now. So
More beer.
more beer. Well, I got to back off on that too, but that's another story. So with that, it's you got the background in Python, which which I actually had a chance to learn 5 years ago. The company offered a 6-day class, which was really awesome, by the way. So
well, Python, C++, those are the strongest. I've actually been exposed to crazy things like APL. So you live long enough, you become an expert in anything.
APL, is that?
Yeah, APL.
It was a Heritage Mobile thing.
I learned APL probably 45 years
yes.
ago.
Yes.
And I haven't heard much about it since.
There is really like only one language vendor left.
That was
really?
the most unusual
Yes.
of all
Crazy language. I hated it.
You hated it?
I hated it.
I loved it. I thought it was really
People who loved it were really, it was just,
Crazy.
it was a passion for those who.
Look, you had to have a special keyboard, or you had to use tri keys you had to do like three keys to. Yeah, please do.
Yeah.
I mean, you want to sit?
No, I just want to be in the.
It was called a programming language.
That's right. That's what it was.
So go ahead.
And it used a lot of English text for its commands. I think, was that the one? Maybe I'm confusing with another.
APL was all those weird symbols.
No, it was the weird symbol.
At row.
Very mathematical. And it wasn't too much programming sense, like most programmings have a consistency of if, then, else, and all this other stuff. It seemed to be more sophisticated with the math symbols. And the
Yeah, like to add up the numbers in an array, it would be plus / number, and it would that's the syntax for adding things to.
Reverse Polish notation.
Maybe a little-ish.
But it had a lot of unusual things. Did they do matrix algebra?
Yep.
Yeah.
Where you had an array of numbers and a square array, and you multiply arrays and divide arrays into arrays, and all this stuff.
Yeah.
It supported some amazing mathematics.
It did.
Most things you could do, but you'd have to write all the software to manage the arrays.
Yes,
This one
but
just did it.
But here's the thing. The first time you run into a web server written in APL, you want to kill yourself.
They actually wrote a web server in APL.
Yes, and I'm not going to say who, but you and I both work for them.
Oh, really?
Yeah.
One of those PhDs that you
Right,
talk
yeah.
about.
It was.
It added uses
Yeah.
to make something do the action of something else.
So it's a pretty fast you make it so right?
Well, the underlying implementation is what matters there, but there was a really short path between writing math as a mathematician and turning it into APL.
Yeah, and also
So it was very easy for them.
About proving you could do the whole problem in one line.
Mm-hmm.
You would do one line of code and it would solve the whole problem.
5 years ago, I wrote The Game of Life in APL.
C tries to do that. The lines get like 6,000 characters long.
Don't get me started on that.
You have to do it in 110 characters.
So
You
it's
do the whole
a-
program.
There's more than language or environment for mathematics.
Yes, there's that.
Yes.
And also MATLAB.
Yeah.
There's another.
MATLAB do a lot of very good.
APL was a different kind of animal. It
Yeah.
was because
It's similar to mathematics.
no. The thing with APL was there was this enormous set of symbols, So for example, let me find so there was, no, I won't do it, but there were all kinds of non-standard symbols in the language. Non-standard meaning you had to either have your own keyboard, special APL keyboard, which would have had to have, I don't know, 60, 100 different symbols on it. Or else you had to have the special translation from a normal keyboard to. And so, for instance, a circle with a dot in the center of it, that was the.
In the product.
No, that was the matrix pseudo-inverse. Not the inverse of a matrix, that was the matrix pseudo-inverse.
It could be
So-
a non-square.
So I mean that you had symbols for everything.
Yeah.
And so a program kind of looked like hieroglyphics.
Yeah.
So the
Interesting.
main strength of that is that the super good at dealing with some arithmetics like matrix manipulation.
Yeah.
Or it's super high in the abstract.
Super high, and it was all vector based.
Yeah.
So anytime you applied an operation, it applied to a vector's worth of data. So you could add 6 numbers to 6 other numbers by adding one 6-element vector to another 6.
And I think during the time frame when it was really viable, they were thinking about writing vector machines.
Yeah.
And
I
so,
was working on a 1130 IBM computer, about the size of that desk.
We had one at
8K of memory.
wait 1130. Wait, 1130 was HP.
No, 1130 was IBM.
Oh well, HP had an 1130.
Well,
also.
they may have had one in the more modern times.
Okay.
But in 1970, it was IBM.
Yeah, you beat me.
1130.
1980-ish. HP had it.
No, not 1980 might have been HP.
Yeah.
But this was 1130. It had 8K of core memory.
Mm-hmm.
Yep.
You guys are old enough to know what core memory is.
Yep. When I sold our institution's 1130 machine for the metals in it, they offered me $1,100, and I said, "Come on, make it $1,130." And they did it. They agreed.
That's good.
Your request was rational and achievable. And
should have kept it, man. It'd be so cool
That's
now.
not greedy.
So yeah, when around the time of the merger, so as I mentioned earlier, I was Heritage Exxon, but I think APL was used in Heritage Mobile. if I'm not
Okay, is that where it came
mistaken. I
from?
think so. And so one of the researchers I worked with at the time, I think was exposed to APL.
Yep.
And hated it so much that he actually took the time to put a piece of paper on his front of the door of his office and talked about all these silly attributes of APL and how kludgy it was.
Now the thing is, all of the culprits that did this have long since left. But now there's this legacy of what do we do with all this stuff?
It's interesting. You said something about the keyboard. I had an IBM keyboard, and we typed in there the APL stuff, and I can't remember. There was like on a modern computer, you have the shift key, you have the FN key, and you have a couple other keys, and they're all like a shift key, just their own style. And the IBM used certain keys as additional shift keys to get all these other characters, and you'd have like keyboard overlays that you could look at saying, okay, that's this key, okay, I can do this, that, and you can type this in. It was not really handy for touch typing.
The only other weirder system that I've ever been in is I programmed in Ada for just a little while.
Ada wasn't so
Ada briefly.
it wasn't so weird. It was just very regimented.
Right, no, but here's where it got weird. So the guys that thought it was NASA, they said, we're going to write everything in Ada so we can reuse it. Nobody thought about the fact that there's no Ada to reuse because it's new. So how can you reuse it? And anyway, so they gave up. But when they were trying, they bought a rational system, which was a machine whose operating system was Ada.
Ooh.
In order to print a document, you had to write Ada.
Interesting.
To copy files, you had to write Ada. It was the weirdest damn thing I ever saw.
Well, there was COBOL, which is really ancient.
Yeah, I've used COBOL.
And it had a lot of text-based stuff in that COBOL. Yeah. And Ada was supposedly COBOL plus 8 other languages on steroids combined and merged in a blender.
Yeah.
And it was supposed to be the end-all language that would be universal replacement for all 8 and more.
Well, they actually did a competition of what, 3 different compiler teams before they picked the version of Ada that they went with.
Ada was green, right? Or
I don't remember, but I knew there were 3 of them.
I know it was designed to replace a lot of other languages.
And in fact, one of the things that bothered me about Ada was the arrogance of the evangelists for Ada.
Oh, well,
I was at
plenty of that.
I was at a conference once where what's her name? Can't remember her name. And she was asked, is there any reason in schools to teach anything other than Ada? And her response was yes, so that you can teach examples of bad programming languages.
Oh, Mike Kluger says that.
Who was?
Which company?
It was the military.
Yeah, the military was hot into it because they had been convinced by some egghead someplace that if they had one language that was, what they were trying to achieve was provably correct. They wanted to come up with a programming language that would allow them to programmatically prove that a program was correct.
They also wanted one to replace all the other languages and to be future proof for the next several decades into the future.
And it had no object oriented.
And rebuild stuff differently.
Yeah.
They wanted to just sort of say, got a great foundation, build on it and grow it for the next several decades, and we don't have to replace and jump this language for another language.
So can we all agree that binary compatibility of programming languages rests clearly on C's shoulders? All the languages that talk to each other do so through a C call style.
Yep, that's yeah.
C?
C.
Yes. Yeah.
Fortran can call C.
Yeah.
Python can call C. Java can call C. .NET can call C.
C engine inside it?
Because the C everybody's standardized on the C call call format basically.
C is like a bad product. Unix.
Yeah, they could do,
Yeah.
You know, but
But
I mean, Dennis
You're saying
Ritchie
C was your interplay between the machine language of the hardware.
Well, it's the binary compatibility layer between all languages. It's not that it was no one appointed it that. It's just that's what happened.
Yeah.
Well, that actually sounds efficient.
Yeah, that's true. So it means you could write in C and you could call it from Python. You could write in, you can't really, you kind of do the opposite, but it's kind of a pain in the butt.
The downside is point.
Well, yeah, but that's, yes, there's, and I'm gonna say this, no matter how much you try to make the guardrails, the real answer is you got to get people who are knowledgeable and responsible. I mean, I know you can do all kinds of things to try to make things better, but in the end, you can pick a language that you think is safe, and I can find people that can do a terrible job in it.
The problem on corporate environment is you have, I mean, especially in defense, you have code base like 20, 30 years.
Right.
But management change every years. And they do not, people leaving, some people are fired, maybe not necessarily want to take and the new management is the necessary to take responsibility of back for the compatibility or whatever code.
You're talking about guardrail safety at the school. I can't remember the name of the computer. It was a mini computer, one rack, about 6-8 feet tall.
Yeah.
And it had a spinning hard drive that was removable.
Yep.
About 14 inches in diameter. And a lot of them did the same thing, and I can't remember the names of the companies. You rattle off some names, I'll probably say that one. But anyway, it was built and it was lent to our school by this company that made them, saying, this is bomb proof. You cannot damage our hard drive. You cannot alter this stuff. And
I know where this story's going.
yeah, this story was going, we got a homework assignment to write in machine code and do some writing and everything to the disk. And we did, and one guy wrote it without limit. And he wrote his message in repeating format across the whole hard drive.
Oh,
And the computer died.
Yeah.
It stopped operating because it couldn't
Well-
read what it needed to
Well,
read.
I think we should have.
It overwrote the operating system.
Yeah.
It overwrote the control system. It overwrote the structural of the hard drive. You know, how you
I've actually done
control.
that. I've actually done that in DOS.
It wrote the
Just
whole
moved
thing.
something and boom.
And the teacher's like, oh, I can't boot it up. I can't this. So he called the company and says, I can't boot this up. He says, well, what did you do? And he says, well, we had a student wrote this program. No, it got out of control. Out of what way? You know, they asked and said, that's the only thing we can't protect is direct writes to the hard drive from machine code.
The only thing.
The only, everything else
Yeah.
would go through their
But it's
operating
interesting
system,
that they
and
use
it
the word
would
only
prevent
for
certain
that.
actions.
Like,
Yeah.
no big deal. It's just this one little.
But doing a direct write to the hard drive by machine code bypassed their operating system, and it couldn't check and prevent things. He says that was the only thing that they couldn't stop. And he says, how long have you had this? 2 days.
There you are.
How many students you had on there? 13.
No,
And he says, 2 days and 13 students, and you trashed our computer.
leave it to a student
That's right.
to be thinking
Yeah.
out of the box that way.
So
I-
this guy
yeah.
shows up 2 days
Yeah,
later and he reinstalls the whole system. He brings in another small thing and he reinstalls the operating system, builds the drive back up. Now, don't do machine code anymore. Well, how am I going to teach basic computer? He says, here's how you do machine code. Load this operation, another application that runs in their software to simulate the machine
Mhm.
code on the machine code.
do it in a sandbox.
And then when that
Virtual
works,
machine.
it's its own sandbox. So that way.
I got
when it
something to
runs
say
out,
about
it
what
runs
your-
out within
your
its
last
own workspace and it doesn't destroy anything except itself. And-
Interesting. That's a
and
funny
that was
story.
their answer to say that's how you can teach machine code.
Yeah.
Don't do direct machine code on the machine. It isn't protected.
It's a bullet. It's bulletproof unless you hit it with a bullet.
Right.
Yeah.
Yeah.
All the executive.
That's like the movie.
But
What is
there
it?
were like 3 mini computers at that time, all vying for the champion space to be a really good. This was, I think, the top of the heap at the time.
Mm.
You know, they did this computer. We had fun with that. The next assignment, he says, is he wanted us to write a compiler to run on this machine to compile and turn it into executable code. And he says, you'll only need to compile up to 16 commands. So here's the 16 commands you use. And use those in your code, and then you write this compiler to compile it into the machine code. Then we'll compare to see that it did the job right. You have the same machine code output as basic. Cool.
What about optimization?
Optimization on the 16 wasn't necessary because it was basic 16, adding, subtracting.
Oh, okay.
You know, very simple things, but it
Yeah.
was like 16 commands instead of the 275 possible. A lot of them are obscure
Yeah.
and not used, but still, it was reduced to a very small set. You had to write a compiler.
Yeah, they made us
He
do.
said, learning how to write a compiler would be interesting thing.
Yeah, it was.
An interest in job interviews
Yeah.
that I helped on a team. We all formed little teams of two, and we wrote.
My school had a year-long project. You had to go through writing a compiler. You wrote the lexer, then you wrote the parser, then you wrote the machine code generator. Then you had to do optimization after that. Yeah.
You mean a whole academic year, right?
Yeah,
Not a whole calendar year.
All right.
Yeah, whole academic.
I was about the same length of time, and a lot of students were taking suspended class or whatever because they hadn't finished.
Yeah, you did yours in assembler though, right?
Yeah.
I did mine in Fortran.
My team finished second in time, and we finished 2 days before the final.
Oh boy. I wanted to inject something here. Your remark earlier was how difficult it is to write a program that's bulletproof.
Yeah.
Say that again. I don't remember exactly what you said, but I just wanted to. It doesn't matter. You said it doesn't matter what the language is.
Yeah, it really doesn't.
And
It's a little bit of everything. You can use languages and tools and whatnot, but you got to have people that are responsible and know how to do what they do.
Absolutely true. I just wanted to.
Two kinds of bulletproofs. One is the bulletproof not damaging the operating system itself, but then the other bulletproof is the program.
Well, that's what I mean.
Is it correct?
Successful to do its job.
Right.
Yeah, that's what I meant.
You can fail that, and it doesn't damage anything else.
Right, but yeah, I would argue that well over half of the people I have met in my career, I would not want them writing software.
Well, I wouldn't write them writing software because I don't like working with them.
And no, because they're an inept. I worked at a hospital information system company, and the company was pretty cool about the fact that when I got there, they ran me through all the different sections, right? Before they sent me off to do my thing. My job was to interface the lab machines to the HIS. So I'd go out to a blood analyzer, make sure the data could come off of it and go into the HIS.
You were basically the first networker for all this stuff.
Well, kind of. This was probably in the mid-90s.
So it's before there was a real network yet to access.
Right. I had to write my own socket code.
Yeah.
Okay. And so the thing about it is I was on the help desk, and the guy at the help desk, I'm sitting next to him. We get a call from Oregon Health. And the guy from Oregon Health says, "We got a problem." And my handler says, "What? Well, what's up?" He says, "Well, one of our patients is pregnant." And I said, "Well, congratulations. Wow, that's cool." And he goes, "No, you don't understand. It's a dude." And it turns out that they use an integer for patient ID. And when they reach patient ID 2 to the 32nd minus 1 and went one higher, it became patient 0. And they just started pasting shit on top of other people's records. Okay. And I said to my handler, I said, "Oh my God, I'm glad we didn't kill somebody. It could have been a diagnosis of HIV, which was a thing then. And if you got that diagnosis, he'd go off himself, and he didn't really have it. It just could be terrible." And he goes, "Well, we've killed people before."
Oh yeah.
Okay. So he said we used to have blood bank management software. Okay. And we accidentally gave the wrong person the wrong blood. Now, when you do that, there's no way to come back from it. Once you put a pint, some bad blood in somebody, the wrong blood into somebody, their whole circulatory system just goes and they're dead. There's no way to fix that. No way at all. Yeah, because think of a blood clot. You get a blood clot in your lungs and it will kill you. The blood clot's this little tiny thing like this.
Related to Barry's question, also related to my previous question. This is some drastic, video, but the thing I described in topic settings, change of management, long legacy code, you end up different people. Is there any engineering sort of solution if you are the new employee coming off and people have a bunch of shit the last 18 years, and your management doesn't really want to take in?
Well, go ahead.
let me just,
Go ahead.
and I actually typed this in the chat because I'm so.
Yeah, just a one sentence comment that people function.
Yeah, that's what I wanted to talk about. Pure functional programming is much more idiot-proof than other paradigms.
But but that's probably the academic setting where in reality, I think what I have described is probably happened a lot of places. I mean, a lot of people got into a lot of shits, in this kind of working environment.
Yeah. Well, here's an interesting thing. Back when I started, okay, yeah, I hate to say that, but okay. They made me do maintenance.
Here, right?
They made me do software maintenance. Before I was allowed to actually substantially change the system I was supposed to be working on, I had to fix bugs, and the person who I fixed bugs for looked through my code. They like, okay. And, and I didn't get to be I didn't get to be CEO the first day I started work, and oh my God, now I work with a lot of young people between 20 and 30. Okay. And they walk in the door and they want to be CEO. They want to get a shit ton of raises. They want to be the principal developer on the project. And it's just like, what the hell? Are you kidding me? You don't even know how to. I mean, first of all, if you're going to make a change in the system, make a change so it looks like the system. Whatever it is, at least then it's consistent. Okay. And then, by God, hopefully when we made it well.
The company I was up here, right? Medicaid. It was a new thing run by nuns.
Okay.
And I thought, hey, nuns, this could be interesting. It was very interesting. And it was about like you. I was fixing bugs, fixing things, and there was a person above me that would review everything I did and approve it, or saying, you do this, fine tune it some more, hopefully you did it right. But they explain the personality, what it is. It says there's a personality in the code that we follow, and a type of rules. In other words, we have indent on certain occasions, like under if statement, you indent, you do this.
Yeah.
And these standards, we want to make sure you conform to the same standard so that your patch looks the same as the rest of the code. It's just been inserted and doesn't have a knee-jerk difference. And even though functionally it may be just fine, but they said it's got to be visually interpreted. So when a person is interpreting, they don't run over something that is foreign to them and saying, what's this? And the idea is, it says 10 years from now, you're not going to be here, but somebody's going to be looking at this code. And if there's consistency through all the different patches and pieces, there's consistency in understanding and following the thought of what's going on.
Right.
And he says, that's what we're looking for, that my boss is looking for, is making sure that this is fine. But I'm looking for technicality. I want to make sure it works.
Yeah.
So it's got to work, and then it's got to fit the grammatical, artistic style of the writing, so that it just fits for the rest.
Yeah.
Because once you get used to that style, you can interpret stuff a lot faster. How it's structured.
Yeah.
So, it's how to do it. And as I went along, she kind of disappeared, and the other person kind of disappeared, and I was like almost the approving person. There was one more person left to approve or disapprove the improvements.
Yeah.
But they kind of faded away as I got along.
Yeah.
And they were doing lots of fixes. There was lots of things. There's something wrong with the code. Something, here's the complaint. Then you'd have to figure out what that complaint is represented by, what failure, and it will fix the failure. So the complaint would be the people who are just typing in data entry and saying, I can't do so and so.
I can't remember ever being somewhere where the source base was holy cow, this is really good code.
Really what?
Good code. I cannot tell you that I've been someplace where I've looked at the repo and been dumbfounded by how well it was put together.
Actually, there were places in this code that was really good.
Yeah.
And I think that was the original code. I think. As I look at it, I couldn't quite figure out which, where, and so on. But I think the original code that was created by a big shop that came in, massive coding, and putting together a whole thing that was running a health plan. But they didn't have any concept. They were creating something brand new. So it was like they had to build it with nothing.
I mean, I've seen code where the if statement, the nested if, was 15 pages long. And the reason we had to change it was that the parser could no longer handle all of the pending crap that was going on in the if statement, and it broke. The compiler couldn't compile it.
Got too long.
Yeah, the if statement got too many steps. It's too long.
They didn't obviously follow the factory design pattern.
No. So you know what I had to do? I cut the if in half.
The operating system.
That's all I could do.
This was had no restrictions like that.
Well, compilers always have something that will break them.
They do, but there are certain rules that are part of the rules that you have to behave by.
Yeah.
But as long as you stayed within those rules, there were no surprises.
Right. Like who in the right mind would make a 15-page if statement?
That's.
Yeah. Oh no, this is somebody else's code. I came in and had to fix the bug. And this, you look at this and go, oh my God.
Limitation that they don't.
And no. Okay. And I mean, I've met people that, well, you know, their management will seize upon someone as a rock star solely because they know how to play the game. And the next thing you know, they spend $3.5 million to use Oracle database to drive a message translation system that translates 100-character message from maybe 100 different machines into a common machine format. And you're going like, and when you start his system, you have to write the script so that it tries to start it 3 times because he didn't initialize all his variables and you can't find it. And you wonder, how do you combat that? Crazy.
Well, what about these the AIs now? Have they gotten into programming?
Yeah, I hear people go, I made mine so I could scrape the pages.
So actually related to AI, also related to APL. Part of AI is that notice you need quite a bit matrix manipulation when it goes to different layers.
Right.
And it's essentially you do a correlation, a matrix correlation, covariance, and then you do a decision. So it's related to APL. I mean, it looks like APL is very good at vector matrix.
It is.
And I remember MATLAB is good at it.
Yes.
RS is somewhat good.
R is a free version of MATLAB, I think, or something.
It's free version of
right?
S.
That's
Free version of S.
Oh, right.
Coming from
Yes.
MATLAB. It's statistical programming.
Oh, is MATLAB based on S? Oh. Yeah, I know R is, yeah.
Yeah. It's actually developed for Fortran. Some guys.
Well, I thought it was developed in C++. From what I understand about MATLAB.
Ooh,
Right?
MATLAB.
it's been around a long time.
Yeah, it has.
Originally from Fortran, but they also enhanced their metrics manipulation.
Yeah.
But what I'm saying is from APL up to now, you guys see some really good language actually doing matrix manipulation, or APL is still the best.
I haven't heard about APL since I learned it 45 years ago.
It's still around, isn't it?
Do you want it to be syntactically easy or
Everything is
fast?
still around.
This is true.
You know,
Even making
it's
sense.
it's a both important, right? I mean, in the end, probably in large scale application, I want to be fast. I want to be like more like a batch type of operation. But you know, in the beginning, I think the MATLAB probably did the job. MATLAB R.
It's interesting. The professor who was teaching me, this is most unusual. When you learn to master this, it says it will be useful to write as as a subroutine and insert other code. And you could do this powerful work on a set of numbers that it receives, and it spits out the result, and the other code can use it, and it would be awkward for the other code to do the same work. So you have this little subroutine that does this intense math work that the other software has a hard time supporting. So you can put out a call to the subroutine that does this APL, and then it comes back. So, and I said, okay, that has a purpose, but I've never seen people who do subroutine calls to other languages very often. I heard it under
Python
or Pascal or one of those others.
Yeah.
They would call to C or call one of the others.
Well, NumPy is that way. Is actually written in NumPy is native, and so you call it Python.
So maybe they're doing it a little more now.
Oh yeah,
But
It's-
earlier,
it's quite
they
common,
were
right?
capable
I
of
think
doing
so.
it.
Actually,
Yeah.
It's quite crucial if somebody, some language can deal with this manipulation in very large scale fast or in small improvement. It can be some foundation of future AI. So I'm wondering, I mean, if there's no more language, maybe APL is something worse. Going back, okay.
if you do C++, there's a version of an n-dimensional matrix library called Eigen that is really fast, which is useful.
Yeah, C++ is also sometimes C. Mostly, if you optimize the C can run faster than C++. But then what I've heard is sometimes if you write some people write MATLAB code super, it can getting closer to the performance of C.
Yeah.
In very few circumstances, you optimize MATLAB code, maybe even go beyond the regular C code performance. So that's a place where you really dig in the matrix.
I've been
the language characteristics,
Yeah.
which could be super important in future AI computing because the building of millions, trillions of transistors trying to implement the power.
I've been less enamored with C++. The standards have kind of gotten nuts. C++ is a lot to learn in order to use, right? Very verbose.
Because they keep building.
And they've just thrown so much into it that I'm of the opinion that, you know, if you're going to be responsible for your own memory and pointers and all that stuff, maybe just write your stuff in C. Don't even bother. Because I can do polymorphism in C. You can make a struct that's got function pointers in it.
That's right.
And you can substitute different functions in for different behavior, for different type of objects. It's pretty easy if you're disciplined enough to do it.
I think a friend of mine told me C++ was great. You can code fast. Faster than in C. But if you code in C, you can code more efficiently, so it executes faster. The same problem.
Yeah.
So you can put the solution to the problem faster, or you can make a more efficient solution that takes longer to develop, but now it executes faster. And if, let's say, the end customer is more concerned about execution speed, then you definitely need to pay attention to where you fly.
Yeah.
But if they're not focused on execution speed, they're more like the bean counter who's out there saying, on delay, 1 month, get this 32-week job done in 1 month. You know, then you're really, behind the eight ball.
Yeah.
It's your resources versus kind of goal.
Yep. Interesting.
That now the corporations, looking at the bottom line, there aren't what it seems to me as a user, I'm not much of a programmer, but as a user, so much stuff is idiotic. I've had a hybrid since 2010. Now I have a Corolla. Instead of shutting down the engine, keeping it off, when I'm in a slowed down rate, it turns on the engine, slow me down, downshift. What idiot thought of that? I don't know. Keep the engine off. No, it turns it on, even in a straightaway.
I wonder if it's trying to store it up in the, like, you know,
It's generating electricity when the engine's off, when the gas engine
Okay.
is off, it's generating. You can see it generating electricity in the battery. But no, it turns on the and it idles at 1,000 RPM, so it's using fuel for that. But it revs it up to 2,000, even 3,000, almost in the straightaway to slow me down because it thinks I want to slow down. Because my foot is off the grass, it thinks I want to slow down. I've seen it in a straightaway where I'm coming off an exit, I'm doing 65, I take my foot off the brake gas to slow down, to just naturally slow down. It turns on the engine, revs me up to 2,000 to slow me down. And I can't do a thing about it. Is there anyone in there that I can call and say, hey, you're idiot?
you know, you should call them because I have a Ranger, and the Ranger in the center console thing, it has a dialogue, these dialogues that pop up when it, you know, you should get some internet and all this other kind of crap. And you got to click OK to make it go away. And so you're driving down the road. Driving? Yeah, while you're driving. And I sent an email to the Ford people. I said, guys, I'm driving. I don't want to leave my eyes off the road to push your button and have an accident and have to sue somebody. This is terrible. Put a timer on the dialogue. They did it. They put a timer on the dialogue.
And I was driving, I met a friend, and I was driving her Honda. It wasn't a hybrid, and we went down the downslope. Her engine was slowing down. I think it's a transmission maker for programming that, not the major fault.
Really?
So are you saying that when you're driving, you get advertising?
No,
you get internet. What is that?
It wants me to get internet so that my car can update.
Okay.
Automatic, software.
Gotcha.
Stuff like that.
Now, it would work just fine getting the update at home, right?
Yeah, it never worked really well, so I didn't do it. I use a USB stick.
Because I'm going to say, you get home, you can make sure that your Wi-Fi reaches your car and you can pick it up.
Yeah. So on the way here,
you're happy eventually, but not right while you're driving.
No, that's true. Now on the way here, we were using our GPS, and the system froze.
And the what?
The system froze.
Yeah.
The center console, everything on the center console froze. Couldn't change temperature, couldn't do nothing because the window's dead. Okay. So I go, okay, with the next stoplight, I'm gonna take the key out of the car, open the door, make it think I'm not here, and then come back, turn it on, it'll reboot. Nope. I
remember the problem.
I had to do a hard reboot through a manufacturer's reboot. Push the button on the volume button and push the 8-track tape advanced thingy or whatever it is. Well, the secret reboot. I had to use the secret reboot to get it to reboot.
And most people don't know it exists.
Yeah. But what's really weird is my car will reboot once in a while I'm driving down the road.
Oh,
Oh, no.
Now, it doesn't affect any of the driving stuff.
Yeah.
Ford Ranger, the new ones.
It's a gasoline car?
Yep.
So
Well, I work for Exxon. Come on.
You just got all this computer in the gasoline car, and that's ridiculous.
Yeah. I've seen the numbers on the EV. The carbon footprint is just as bad. There's just
No, I recommend hybrids. I'm getting 62 in my car, 62 miles per gallon.
yeah. How long have you had it?
This one, 2 years.
Okay.
Before that, I had a Hyundai Ioniq, and before that, I had a Prius.
62, is that a hybrid?
How many years do they last?
Sorry?
How many years did they last?
I never had problems with any Toyotas. I had the Prius for about 7 years, traded in.
You're talking hybrid though, right?
Hybrids.
Yeah.
2010.
Yeah.
Even then, I was getting 45 miles per gallon in 2011.
Hybrid makes perfect sense.
What's the speed of the generator that charges?
It generates when you're, first of all, the original Prius, we get the driving miles by shutting the engine down when you're working on the
Yep.
And then
This is the charging engine. It charges your battery?
No, what the engine is shut off, the gas engine is shut off. That's how it saves miles. And a lot of cars nowadays, regular cars, They shut, when you're at the light, they shut up.
Yeah, mine does.
Now,
I
the
hate that.
engine is turning
You could turn it
white.
off.
Yeah, I know, but the thing is, it won't stay off. Every time we start the car again, it's on.
No, you go to your thing and there's a default setting.
Oh, I didn't know that.
Well, at least there's on mine.
Yeah.
That's what
Yeah. I hate that feature. I don't even know what the intent about it.
hybrid is.
Yeah.
gas,
50 years
and
ago, my
battery.
school built a
Oh, I
hybrid
supervised.
car.
Yeah,
They
I
took
can't remember,
a
but yeah, I'll look into that.
Gremlin car, those funny looking Gremlin cars,
yeah.
chopped it and shortened it, made it a stubby little thing. Put about 10 LED batteries inside the thing, and put in electric motors on the wheels.
Yeah.
And they put in a 14 horsepower generator motor and a 50 horsepower generator.
Yeah,
And that would run at 5,000 RPM.
Right.
And it would run the generator at 5,000 RPM, and it would charge the batteries. And when the batteries were full, it would shut down.
Yeah.
Not when you're going downhill, not when you're going uphill, not when anything. It only shut down.
Right, well, your software's not as sophisticated as his.
No, nowadays the hybrid will recharge when you're going downhill. Or
Right, yeah.
coasting.
Oh, you're saying it's getting free energy from going downhill.
Yeah.
To charge up.
Yeah. And he probably has a smaller engine in his car too, right? Is your engine in your car smaller, the gasoline engine?
It's a 1.8.
So it just,
It's a typical
it-
engine.
does it draw, it actually pushes the car if you don't have a battery.
If I push the gas, and actually this hybrid, if I really throw it, I want more power, it'll use electric and gas.
Okay,
But no, it's
So there's
usually,
electric motors and a gas engine both. turn
Yeah.
yeah. But
Oh,
one or the other, and it like now with the lithium batteries, it will switch. So discharge and recharge, discharge and recharge that quickly. Just to keep it midway.
Mhm.
But I
But-
was asking a long time ago, I saw YouTube back 10, 15 years ago. Somebody in Germany, I think, built a B-52 scale, literally about this size, with actual 8 jet engines this size in it. And I was thinking, why can't you put one of those inside of an electric vehicle to recharge it?
Yeah.
But then I talked to one of the guys over there in New Factory, Raven, and they said, no, it takes 180 kilowatts in 1 hour to recharge the battery. That's
Yeah, geez.
180.
Yeah, but a hybrid makes sense because in an EV vehicle, if it's only electric, your battery will eventually erode so much that your distance is going to get severely hampered. It'll go down to like 60% of the distance of when you bought it in 5 years. But as a hybrid, you don't really notice it because the engine is just recharging it and making up for it.
Yeah.
So at some point, let's say 4 years down the road, your hybrid's probably using more engine. So your gas mileage probably goes down a little bit, but it's still better than a gas vehicle.
You're charging continuously.
Yeah.
That doesn't sell on.
Yeah.
And you have to put in fuel to run the charging system to keep it charged.
Right.
Because when I'm going downhill, it shuts off the engine, except when the downshifts. It shuts off the engine, the gas engine, and it's
Do you have
recharging.
2 gas engines?
One gas engine.
And a generator,
And what's the generator connected to? What drives the generator?
the gas engine.
I don't know. What drives the generator?
What turns the generator?
Okay, so.
Is it a hand crank? What turns the generator?
So, I don't know the actual
It's
physical.
a squirrel.
But
It's a hand crank.
if I'm uphill, I can use all electric to get me uphill with the batteries. They'll drive the
The
wheel.
batteries turn.
The battery will
electric
drive the
motors
wheel.
to drive the wheel.
Speaking
Now,
of electric
When I'm
vehicles,
going downhill,
Oh, yeah, we got the.
that function
Give us
is
your wrap up.
reversed.
Yeah.
The motors become just-
Do we close this out?
So that's what I mean.
I don't know.
I'm gonna leave it.
You know, yeah, let them, yeah.
Except I have gas powered engine, something like that. And if I'm sitting there, it'll recharge the battery. If I'm just sitting. And the battery needs recharging, or I'll just recharge the battery.
Apparently, the gas
You go to the
engine turns those motors that generate charge.
It directly drives the car and it recharges.
So everything's all connected and it
Let me
just
read you
uses
guys
whatever it can.
One thing that people are forgetting, they're not thinking about it, and my pet peeve from for a decade or more. Let's say you need an operation.
Yeah,
So you go interview the guy who makes the utensils.
yeah,
You interview the guy who made the table.
yeah,
You guys interview the guy who made the light.
yeah.
You don't interview the doctor. What do you need to do? He's just an operator. He just operates all the equipment. The doctor. You don't need to operate. This is what's happening on our roads. We have scientists interviewing the road makers, the city planners, the thing. Nobody's interviewing the drivers, the bus drivers, the truck drivers, the cab drivers. Nobody's interviewing them, trying to learn how traffic works.
Yeah, that's true.
Traffic. I don't need to listen to traffic radio. I know at this hour that road is going to be full. Nobody's interviewing them.
Yeah.
All our roads, all our cars, garbage information. Garbage in,
Garbage out, exactly.
Yeah.
That's exactly right.
Well, thank you guys. Had a good time.
Thank you for everybody who joined us remotely, so.
Thank you.
Yes, thanks everybody. We're gonna take off.